10.6. In this lesson, we will be focusing on finding the surface areas of pyramids and cones. To the right here, we have what we call a regular pyramid. Remember, regular means all sides are equal. So this polygon here is a pyramid with all of its sides equal. To be more specific, we can call this pyramid a square pyramid. Also, all the lateral faces of this pyramid are congruent isosceles triangles. Remember, isosceles just means a triangle with at least two sides equal to each other. The slant height of this pyramid is just the height of any of these triangular lateral faces. So right here, this red line represents the slant height. Now I'm going to show you how to calculate the surface area of a regular pyramid. To calculate the surface area of a regular pyramid, you just take the base area and add it to the lateral area. In this case, the base area would just be S times S because we have a square as the base. And here, the lateral area, since we have 4 triangles, we need to multiply by 4. And to calculate the area of one triangle, we just take half times the base, which is S, and multiply by the slant height of L. And this is where it comes from. We can rewrite this expression as half times 4 times SL, and let 4S be P. P equals 4S to make it simpler. And we can multiply that to L. And the reason why we want to do this is because, as you can see, you got 4 S's here. For the base. S, 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 S. 4 times S times L. So it's easier to remember the formula. So to summarize this, the formula for the surface area of a regular pyramid would be the base area plus half times the perimeter of the base. Remember, P equals 4S. P just stands for perimeter. I forgot to mention that earlier. Times the slant height. And again, this is measured in square units. All right. Now, we can practice this right now. Surface area equals base area, 10, 10. So we could do 10 squared plus half. The perimeter would just be 4 times one of its sides, 10, and multiply by the slant height of 13. And after doing the math, you should get 360 centimeter squared. Now let's take a look at another kind of regular pyramid with a base that has a triangle. We call this a triangular pyramid. And the same idea in calculating the surface area is the same. So again, base area plus half times the perimeter of the base times the slant height. So to find the area of the base, what would you do? Okay, it already gave it to us, so it's 3.9 plus half. The perimeter will be 3 times 3, because you have 3 equal sides. Remember, this is regular, so all of these sides have to be congruent. Okay, so it's either you do 3 plus 3 plus 3 or 3 times 3, and times the slant height, and you should get about 21.9, and if you were to round this, 22 meters squared. Now let's do one more square pyramid. So you got a base of a square, 16 on each side, 16 squared, plus half, 16 times 4 to find the perimeter of the base, and times the slant height, 15. And we do the math, 256 plus 32 times 15, and 736 inches squared should be your answer. Let me just circle that answer in red so you can see it better. The surface areas of cones. Yeah, just think of an ice cream cone. The height of a cone is just the distance between the vertex. Okay, so this is the vertex, the tip of the cone, and to the center of the base of a cone. So here, this could be considered the height of a cone. The lateral area of a cylinder is just the distance between the vertex and any point on the edge of the base. So from here let's use this one, vertex to any point on the edge of the base. So this edge of the base is made up of many points. This is called the edge. Okay, and to calculate the surface area of a cone, you also take the base area and you add it to the lateral area of the cone. So again, the base area is just a circle, so you just use the formula of calculating the area of a circle, pi r squared, and you add it to the lateral area, pi r l. To get a animated proof of this formula, please watch the video on my website. So in summary, the surface area of a cone will be base area plus lateral area. S equals pi r squared plus pi r l. And remember, L stands for the slant height. Which we have here. So this is the slant height. And this will be the height of the cone. We have two different heights. Okay, let's do some practice using the surface area of a cone formula. To find the surface area of the cone, okay, leave your answer in terms of pi. So I'm not going to ask you to multiply it by 3.14 to make things simple. So surface area equals pi. Okay, we have a radius of 7, so you could just go ahead and write 7 squared. And pi, substitute in 7 for the radius again, multiply by the slant height of 24. Well, basically, I just took this formula and I substituted in for its corresponding numbers. And you should get 49 pi plus 168 pi. Then, you keep simplifying this, you should get 270 pi inches squared. Okay, one more. Surface area, again, is pi, radius 8 squared, plus pi, radius 8, slant height 15. Okay. And then we get 64 pi plus 120 pi, which equals 184 pi centimeter squared. On the test, you might be asked to multiply by 3.14 in place of pi, then you will have to. Okay? Okay, and one more. Surface areas of spheres. A sphere is a solid formed by all points in space that are the same distance from a fixed point called the center. So this is a 3D looking circle. Okay, so our formula will be defined as S equals 4 pi r squared. Please watch the animated proof on my website. And I also have a proof for the pyramid. So, pyramid, cone, sphere. SA, surface area proofs. Okay, and let's practice. Find the surface area of a spherical soap bubble with a radius of 0.5 inch. So 4 pi 0.5 squared. Okay, and then we can do the math, and you should get 3.14 inches squared. In this case, I use pi equals 3.14. Find the surface area of Europa, one of Jupiter's moons. The diameter is about 1950 miles, so you need to divide that by 2 before you plug in the radius. So the radius should be divided by 2, 975. So surface area equals 4 pi 975 squared. Yes, this is a little ridiculous. So again, we won't give you a problem like this in which you will need a calculator. But just to give you an idea that this is how you would calculate the surface area of a sphere. And that concludes our lesson. Remember, don't forget to watch the proofs on my website.